So, hello everyone, welcome to our Ask Geology, a whole new way to understand our Mother Earth. So, in this today's 7-minute numerical, we are going to discuss about one numerical related to your general geology, and it is asked in 2019 GATE. And it has a important. This is actually an important question, and more frequently these type of questions are coming in GATE as well as NET exam. So, the question is, assuming airy isostatic compensation, the depth to moho, okay, the depth to moho, this moho is the crossed mantle boundary, crossed mantle boundary, okay. So the depth to the moho from a point located 2 kilometer above the mean sea level is dash kilometer. So as we know, there's these isostatic compensation methods, okay. These are basically simple gravitational balancing between the continental crust, oceanic crust, and the mountain that is also coming under the continental crust. So it is given that the depth of compensation for the crust at mean sea level is 30 kilometer, and the density of the crust and upper mantle, density of crust is 2.67 gram per cc, and density of your upper mantle is 3.30 gram per cc respectively. So in this case we have a very simple formula to calculate the root depth or root zone, okay. So you can see that in Aris concept and Airy and Pratt, okay, these two models, they represent the local isostatic compensation where the Venins, Vening, MEINESZ, this elastical plate model that represents the regional isostatic compensation model, okay. So in this Aris compensation method, you can see what is root zone and anti-root zone. Root zone is present beneath a mountain, and anti-root zone is present beneath any oceanic crust. Okay, this is the difference between the root zone and anti-root zone. And in this case, you can see for this H1, okay, this is the MSL, this is the MSL or the mean sea level, and above the mean sea level, there is one mountain is presenting having height H1. So the concerned root zone associated with this H1 will be R1, and for the height of h2, if this is actually considering where a mountain which is present at h2 height from the mean sea level, then the associated root zone that will be associated with this h2 will be r2, okay. So then what will be here, this h1 is given to be 2 kilometer, okay, and this t is given 30 kilometer, this t is given to be 30 kilometer, that is the thickness of the crust. And density of crust, what is given, that is 2.67, this is gram per cc, and density of mantle, that is upper mantle, that is 3.30 gram per cc. So these are the data we have, okay. And now it is asking the total depth, okay. This is the total depth. You can see, assuming Aris isostatic compensation, the depth to the moho means starting from the continental crust to the core mantle boundary, and this is the core mantle boundary, okay. This is the, sorry, this is the crust mantle boundary, that is the moho. So we have to calculate the whole thickness, and in this whole thickness, what is mentioning, this h1 is the total thickness. For this total thickness, how it will be calculated, that will be h1, that is the height of the mountain, plus of t, that is the thickness of the continental crust, plus of r1, that is the root zone associated with this mountain, h1 height mountain, okay. So for this we have a very simple formula. You can see, this is r1, this is a root zone, this is the root zone depth or thickness, this h is the height of your mountain, height of mountain from msl, mean sea level. And remember, this height is in kilometer. Always remember, this height is in kilometer. Then rho c, that is the density of crust, rho m, this is density of mantle density, and rho c, this is the density of the crust, this is the density of continental crust. Okay, now fine, we have all the values. So this r1 is equal to rho c, this is 2.67, cross of height is your 2 kilometer, and always remember this h is represented in kilometer, divided by 3.30 minus of 2.67. So if we calculate this, then the answer is going to be 2.67 cross of 2 divided by 3.30 minus of 2.67. This is 8.47 kilometer. Okay, this is 8.47 kilometer. Now we have calculated up to the root zone. Then the total thickness, the total depth or total thickness we have to calculate, because the question is asking that one. That will be h1 plus of your thickness of the continental crust plus of the root zone r1. So here the h1 is 2 kilometer, plus of thickness is given to be 30 kilometer, plus of r1 we calculate 8.47 kilometer. So what is the answer? This is 30, 32, 840, 40.47. This is 40.47 kilometers. So this is actually the total depth up to the moho. Up to the moho means that is the crust and mantle boundary. Okay. So our answer is 40.47. So see, our answer is 40.47 kilometer. So what are the other things associated with this? Let me just change the color. Okay, so in this case, one thing is your root zone and anti-root zone. Anti-root zone is associated with your oceanic crust. Root zone is associated with your mountains. Okay, so in this case, simple gravitational balancing is maintained. Okay, simple gravitational balance is assumed. Okay, so in this case, you can calculate this formula r1, that is the root zone depth or root zone thickness, is equal to rho c h1 divided by rho m minus of rho c. You can calculate simply. If you just calculate the whatever the pressure acting in this here and whatever the pressure acting here, then you can equate both of them, then you can find this formula. Similarly, for anti-root zone, you can calculate this r0 is equal to r0 for anti-root zone, r1 for root zone. This is rho c minus of rho w into d. This d is your water depth. This is your water depth. And rho m minus of rho c, because in this case you can see, if we just calculate the pressure in this case, in this region, okay, then there is water is also present, and the volume of water or the depth of water, okay, that will also induce some kind of pressure, some amount of pressure. Okay, so because this isostatic compensation, these are nothing. Isostatic, this is simple balancing. Isostasy, what is isostasy? This is simple balancing. So here in this case you can also see that this is your root zone r1, this is for airy, for anti-root zone this one, and this is for Pratt. You can see in airy hypothesis the depth of compensation is changing. Okay, the depth of compensation is also changing, but in this case, what is the depth of compensation is fixed. Okay, the depth of compensation is fixed and density that is changing. Okay, so hydrostatic equilibrium for mountain, so you can calculate, this is the root zone and this is the anti-root zone. Hydrostatic equilibrium for ocean floor. Root zone is related to your continents. Okay, continents, and anti-root zones, these are associated with your oceans. Okay, and this isostatic balance means they are considering the continental crust or the oceanic crust. Okay, and from this concept, okay, from this isostasy concept, the evolution of your Bugger anomaly in gravity method, okay, in the gravity, geophysical gravity method. So we use the Freer anomaly, Bugger anomaly, and these are also associated with the isostasy. Okay, because in isostasy we also consider the mass. Okay, so This is I just want to add this one. So you can see this in the topography. If we are considering the topography, if we are just considering the topography, whether it is overcompensated or compensated or undercompensated. Okay, you can see del GB is representative of your Booger anomaly. Okay, this is del GB is your Booger anomaly. Okay, you can see in this case when it is overcompensated, del GB is still in negative. In the negative side, you can see this is positive side and this is negative side. The gravity anomaly is del GB is negative. In this case, you can see if it is completely compensated. Okay, the topography that is present up, and you can see del GB is still in the negative side. In this case, you can see del GB is still in negative side, and if it is undercompensated, then del GB is still in the negative side. So in this case, for topography, okay, topography, we are considering the hilly topography, then del GB is maximum case that is negative. Okay, and another thing is that we cannot tell that the Booger anomaly is always negative. In this case, we are considering one continental crust or one topography. Okay, but in case of islands, in case of islands, what will happen? The oceanic crust is surrounded. Okay, there in between there is one continental crust. Okay, continental crust. So in this case, the Booger anomaly associated with this island as compared to its surrounding, that will be different. Okay, in this case, particular in island case, the Booger anomaly will be opposite. But in this case, what actually happening in mountain or any topography is present, del GB your Booger anomaly is always negative. ओके, इन दिस केस ओवर कॉम्पेंसेशन में क्या हो रहा है? योर नेगेटिव फ्री एयर अनोमली, नेगेटिव फ्री एयर अनोमली, बिकॉज the computed route and the real route, you can see the real route is present at a deeper depth, but the computed route that is present at a shallower depth as compared to a real route. So we are having a mass loss. Okay, or we are having a difference in the route thickness, and that is represented by your negative free air anomaly. Okay, यहाँ पर if it is fully compensated, then there will be no free air anomaly, because whatever the real route will be there, the compensated route will be the same, and the topography will be represented by accordingly. Okay, and if it is your undercompensated, then that will be associated with your free air anomaly. So can we just write down that if the real root is larger, this is one formula type. Okay, if the real root is larger, it is overcompensated. Okay, if a real root is larger, then it is overcompensated, compensated. Okay, this is overcompensated. You can see the real root is larger means present at a deeper depth. Real root, it has a greater value. Okay, magnitude. Okay, only magnitude. So many a cases this Booger anomaly and free air anomaly, they are just coming into questions. But remember that this Booger anomaly is not always negative. But in this case, when we are just considering the topography, it is creating that kind of situation that where the del GB Booger anomaly is always negative. But in case of island, okay, then that will be opposite. Okay, so hope this is clear to you. So thank you, save our mother earth. And if you are interested to join our group, okay, then these are the phone numbers, these are the email ID, or there will be a link tree that will be provided in the description box. By clicking on that, you will be getting access to all our social media platform, and you can visit our website also for more information. Okay, so thank you very much.